Let's take a look at some of the homework problems in section 5.5. And in this section, we're looking at U-substitution. So the first problem here gives us the integral of e to the u divided by 7 minus e to the u quantity squared du. And first, we're asked to find a substitution to rewrite the integrand as negative 1 over x squared dx. So I'm going to go ahead and start by giving my x value as 7 minus e to the u. And note that you always want to let u be equal to the inside of your composite function, if that is available. All right? So if x is equal to 7 minus e to the u, it then immediately follows that the differential dx is equal to negative e to the u du. And in this problem, I would like to give e to the u du as a quantity in terms of x. So negative dx is equal to e to the u du. So a proper substitution here is going to yield the integral of negative 1 over x squared dx. So I was able to rewrite the integrand as negative 1 over x squared dx. So right there for my x value, I have 7 minus e to the u. And then for my dx, we have negative e to the u du. All right. So next up, we want to go ahead and evaluate the integral. So evaluate the given integral. So my first step here is to consider the integral of negative 1 over x squared dx. I'm going to go ahead and just rewrite this integral as x to the power negative 2 dx. And of course, the negative value is still on there. Okay, just kind of drop that, so make sure your negative value stays on there. All right, so when we integrate x to the power negative 2, we get negative x to the power negative 1 divided by negative 1. So add 1 over add 1 as those powers. And then finally, this will be equal to just simply 1 over x when we clean up. All right, so with integration completed, my next step is going to be to back substitute. So keep in mind that x is equal to 7 minus e to the u. So when I back substitute, I get 1 over 7 minus e to the u, quantity plus c. Do not forget that plus c at the end of each one of your problems. All right. Let's look at the next one. All right, so here we're going to integrate cotangent of 2x dx. All right, so in this problem, what I'm going to start with is just rewriting this. We don't really want to integrate cotangent. That is a difficult function. So I'm going to express cotangent as cosine over sine. So in this case, we're finding the integral of cosine of 2x divided by sine of 2x dx. Again, here, the problem wants me to do a substitution so that we can rewrite the integrand as 1 over 2 u du. All right, so I'm going to let u be equal to sine of 2x, which is going to make my differential du equal to 2 times cosine of 2x dx. And note that I had to use the chain rule when I found this derivative of sine of 2x. All right. So I would like to solve here for, I do have a cosine 2x dx in my problem, so this 2 is extra. I'm going to divide both sides of the equation by 2, so 1/2 du is equal to cosine of 2x dx. So finally, if we make our substitution, we do get the integral of 1 over 2u du. So that worked out very nicely. I was able to get the integrand that the problem asked for. So specifically, u is equal to sine of 2x, and then du will be 2 cosine of 2x dx. So on to the integration in this problem. The integral of 1 over 2u du. Note that the 1 over 2, the 2 over there next to the u, can be factored out. So we can write this as 1/2 times the integral of 1 over u du. The integral of 1 over u, of course, will be equal to natural log of the absolute value of u. So we get 1/2 ln of absolute value of u. All right, our next step would be to back substitute. So again, remember that u is equal to sine of 2x. When I plug that back in, replace u with sine of 2x, we get 1/2 times the natural log of the absolute value of sine of 2x plus c.